Hey everybody, so we're going to start moving now in another direction with exponents, because if you've noticed, everything we've done so far has given us exponents of positive numbers. Well, it makes sense that there's probably expressions that have negative and zero exponents to it. So we're going to talk about that in this next batch of videos. And so we're going to start by talking about what a zero exponent is. And so I have a picture here, right, where it says 0 exponents and 5 to the 0 equals, and we're not quite sure. So we're going to look at that and see if we can kind of figure that out and give you guys some sort of intuition, knowing what you know now about what maybe a 0 exponent would be. So let's take a look at what the definition is from our resource. It says any non-zero number, and I've wrote or term, to the 0 power is 1. So what they're saying is if we take that expression that we have out here, right, 5 to the 0, we write that out, they're saying equals 1. So I kind of want to look at that a little bit and try and explain that to you guys about why maybe that is, because it's that case with anything. If you have x to the 0 power, it's 1. If you have if you have y to the 0 is 1, 107 to the 0 power is 1, anything to the 0 power. And you got to be careful because it looks kind of like degrees, but in the books and everything, it looks more like an exponent. So anything to the 0 power is 1. So let's kind of look at maybe what an example of that looks like and why that is the case. So if we take something like, let's say that we've got 3 to the third over 3 to the third. Now, we know from what we know about the laws of exponents that when you deal with monomials that have exponents and they have the same base and you're dividing, it means you can take that and you can go 3 to the 3 minus 3 power. You can take your exponents and you subtract the denominator exponent from the numerator exponent. Right? So if we have 3 to the 3 minus 3 power, if you do this 3 minus 3, that gives you, it gives you 0. And so then you get 3 to the 0 power, and then so you're like, okay, well, I can do that, but how do I know that that equals 1? Well, let's expand this out, and then I think you'll see why. So I can rewrite the numerator in expanded form as 3 times 3 times 3. And then I'm going to rewrite the denominator in expanded form. And it's going to wind up being the same because they have the same number of factors. Remember, exponents is a way of showing repeated multiplication. So you have 3 times 3 times 3 in both the numerator and the denominator. All right, and then so if we use what we talked about before where you kind of group them together. Sorry, that blue doesn't really work, does it? You group them, so you've got this set, you've got this set, and you've got this set, right? So 3 divided by 3 gives you 1. 3 divided by 3, your next set, gives you 1. And then 3 divided by 3 gives you 1. And 1 times 1 times 1 gives you 1. So essentially what happens is when you have something to the 0 power, it means that all the factors and everything have sort of canceled everything out and you're just left with this identity. So hopefully that makes a little bit of sense. So when you're doing it, if it doesn't, pretty much the main thing you're just going to have to, focus on is that anything to the 0 power is always going to give you a value of 1.